is Mr. G here. I wanted to share something with you. I know that a lot of you have been stuck inside like I have been, and if you're like me, you're probably getting a little bit bored. So I wanted to share some puzzles, challenges, if you will. I oftentimes in my classes posted challenges or gave you kind of fun little side math projects. Just something for you to do if you were finished homework in class. So think of these kind of like that. They're totally optional. You don't have to do them if you don't want to, but I wanted to give you the opportunity. 3 math puzzles. Let's start with the first one. And I'm going to call this number descriptions. So the way that this works is if we take a number, 4, 5, 7, 9, 2, 8, 8, 1, something like that. Now the way that you do a number description, so if this is the number, so this is our number, the description of the number, what we do is basically count up all the different digits. So we would start off with how many zeros there are, how many ones there are, how many twos, threes. So for our number up here, we've got no zeros, so we put a 0 here. We've got only 1 1. We've got 1 2. There's no 3s. We've got a 4. We've got a 5. No 6s. 1 7. 2 8s, and a 9. So the description for our number is this, right? If you notice, we've got 10 digits here. 1 2 3 4 5 6 7 8 9 10. We've got 10 digits describing our number up here. So it's kind of like an encoding of sorts. Now the challenge here is to find a number that is the same as its description. That's your challenge. Now obviously this number was never going to work for this challenge, right? We've got 1 2 3 4 5 6 7 8 digits. So only 8 digits here, whereas our description is always going to have 10 digits because, there's 10 different types of digits, 0 to 9. So already we know that it's going to have to be some 10-digit number, and it's up to you to figure out what that 10-digit number is going to be. Now for an extra challenge, the extra challenge here, if you'd like to try it out, would be to find the same sort of number. So find a number that is the same as its description in a different number base. So that's your next challenge. If you're not familiar with how numbers work in different bases, I would encourage you to look at some of the videos in the description that talk about how different number bases work. And if you're interested in finding out more, I'll leave that up to you, and maybe I'll do another video about this in another time. So there's number 1. And this one I will call persistent multiplication. So the whole idea with this is I'm going to start again with any number. So let's take like a 4-digit number. Let's do 4 6 8 3. Now what we do with this number for this sort of game or for this challenge, we're going to take this number, we're going to multiply all the digits together. So we're going to multiply all these digits together. So it's going to be 4 times 6 times 8 times 3, and that's going to give us our new number. Now if you don't feel comfortable doing that in your head, I encourage you to grab a calculator right now, like I am going to. So using my handy dandy calculator, 4 times 6 times 8 times 3, that gives me the number 576. And if you're familiar with the word persistent, as I am sure some of you are, means you keep doing it over and over again. So for this one, we're going to keep going. So again, our next step is going to be to take all of these digits and multiply them together. So 5 times 7 times 6. So now we get 210. And we'll do this again. So 2 times 1 times 0. I don't need the calculator for this one. Hopefully you don't either. We see a 0 here. We know the whole thing is going to end up as 0. And at this point we stop. There's only one digit. We can't do this anymore. So there's only one digit, and so we stop because we have nothing to multiply together. And now we can look at this and see that this took us 1, 2, 3 steps. So it took us 3 steps before our process stopped. So the challenge here is to find a number with the most steps before it reaches a single digit. Now you might just think this is going to be a whole bunch of guess and check, but already just from our example up here, we can see that we probably want to avoid some things, right? It's not going to be totally random guess and check. For instance, 0 is really bad. If we have 0 anywhere in our number, we know the whole thing's going to multiply to 0, so that automatically kills everything that we're doing. So we really don't want a 0 hanging out in our number. So we want to avoid these zeros, and we want to try to avoid things that also give us zeros. So for instance, if we look one step before that, what about this number gave us a 0 here? See if you can figure that out for yourself. The extra challenge for this one is to see if you can write a code that can check a number. So whether you're comfortable with Python or any other coding language, C, C++, this is a great challenge for you for those that are interested in coding, or maybe if you're just interested in learning. This would be a great opportunity for you to do that as well. So write a code that checks a number, or if you really want an extra challenge, searches for numbers with a lot of multiplication steps. So if you have a code that checks the number, if you can write a code on top of it that searches the numbers, so generates numbers and then checks them and reports back to you on which ones have a lot of steps. That's what we're after here. We want the most steps possible. That's your challenge there. So see how high you can go. I won't tell you the answer for this one, but again, I'll in a couple days, who knows, I'll maybe give you another hint or post the answer. You can try and find it for yourself. Our last one here is going to be about dice. So we'll call them mystery dice. So the whole idea is that you have 2 dice. So this is going to be my attempt to draw some cubes here. Not the worst. And if you're familiar with regular dice, you know that there's 6 faces, 1 to 6 on each face. So this would maybe be like a 1, I'll maybe do it in a different color. So this would be like a 1, 2, 3, 4, 5, and a 6, right? So there's all your faces, there's all of your numbers. Now for this challenge, you've got a second blank die. So this one's going to be blank, and you want to label all the faces so that the probability of getting each number 1 to 12 is the same when the dice are added together. So if I rolled, for instance, a 3 on my first die, and I don't know, let's say I had a 4 somewhere on this face and I rolled that 4, add them together, I get 7, using the numbers 0 to 6. So this is probably going to look a little bit different than our conventional die. It's going to be a little bit different. We can have 0 on it, we can have 6, and I should also add here repeats are allowed. So if you want, you could label your die here. So for example, I could label my die here 1, 1, 2, 3, 4, 4, if I really felt like it. I could have 2 1s, 2 4s. You can check for yourself, but this is not going to work in terms of equal probability. I'm not going to go through here how exactly the probability would work and how you would calculate the probability for these different die. If you're interested in that, there's plenty of videos out there that go through the basic calculation for probability when you add 2 die together, or 2 dice. So I encourage you to check that out. Just like all the other ones, there is an extra challenge here. So our extra challenge here is how many different ways could you label 2 dice so that 1 to 12 has equal probability with any numbers. So you're allowed to use any numbers you want. Label each of the faces with whatever you'd like. And so how many different ways could you do that? So play around with that. Keep in mind any numbers you want. So you get really creative with your solutions here, and I would encourage you to give that a try. That's all I got to say for this one. I encourage you to take a look at these 3 different challenges: mystery dice, persistent multiplication, and the number descriptions. Each of them has a challenge and an extra challenge. So if you finish the earlier one and you want something that's a little bit more challenging, a little more difficult, give the extra challenge a go. See if you can extend your reasoning, your thinking. If you're feeling stuck on these, I encourage you to reach out to other people in the classes, work on them together, come up with collaborative solutions. All of these have answers that are online. So if you don't want to get spoiled, I would encourage you probably to be careful about what you're searching, because you might stumble into an answer if you try and do some research online. If you have questions about these questions, feel free to send me a message, either by email or through the chats feature on Teams. And I will see you in the next video.